Let us look at how a regression problem can be formulated and solved. So we know the problem of learning a parametric function f of wxi from data. We made the assumption that the function is linear and the function is of the form yi is equal to w transpose xi. Remember, yi is a real quantity, it need not be an integer. Now, we are given n data points. The problem is similar to the intuitive problem of, say, line fitting. You would like to find a line that fits well, best for the set of data points. Remember, not all points will be on the line. There will be error, there will be fit error, there will be error in fitting, and what our problem will be finding a W that suits most of these points or that suits this set in the best possible way. We can write this problem as y1 is equal to, say, I'm writing in a vector form here y, say x1 transpose and w. Similarly, this is yn is equal to xn transpose w. Remember this, you cannot possibly find a w that suits this equality for all the points, and our requirement will be now, if this is a vector y which is n by 1, and if this is a matrix x which is of size, say, n by d, and w is d by 1. Yeah. So if this is the y, x and w, then our problem is in finding an error e. Error vector will be y minus xw, and what we would like to do is minimize E transpose E, or sum of squared values of these individual elements. This is also similar to, say, for example, like I is equal to 1 to n yi minus w transpose xi whole square. How do we do that? Our problem will become now minimize over w. We want to find the best w. Y minus xw, y is a vector, x is a matrix, w is a vector, transpose y minus xw. Or this is nothing but, if you just multiply and expand, you will realize there is a term y transpose y plus w transpose x transpose xw minus 2 w transpose x transpose y. And what we would like to do is differentiate with respect to w this entire term and equate to 0. This is independent of w, this is not going to come. This is a quadratic in w, So the differential will become 2x transpose xw, and this is a linear in w. This will become minus 2x transpose y and equal to 0, or x transpose xw is equal to x transpose y, or w is x transpose x whole inverse x transpose y. What is x transpose? X transpose will be a D by N matrix, X will be N by N matrix, so this will be a D by D matrix, and X transpose will be D by N, and Y will be N by 1. So this gives us a closed form solution to the regression problem, linear regression problem, from the data. What's the disadvantage of it? Two issues that we can notice at this stage. One, this requires huge matrix and matrix inversion in many practical situations. Particularly when the dimensionality is large, this is not very attractive. The popular trick could be to design an iterative solution for finding W. Say, for example, start with a initialization and update W based on some properties. We'll see this class of algorithms or solutions at a later stage. The second issue could be here that if a new data point comes to this matrix, how do you handle? Indeed, this is a very, very nice way of looking at an optimization problem, that you have a closed form solution for when n and d and data and everything is known to you, you can directly compute. And that way, this is extremely useful and a very popular solution for the mean square error style of problems.